From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 336, recorded live Thursday, September 6th, 2012. This episode is brought to you by Telerik, offering the best in developer tools and support. Online at telerik.com. And by Franklins.net, training developers to work smarter. And now offering GesturePak, a powerful gesture recording and recognition system for Microsoft Connect for Windows developers. Details at gesturepak.com. In this episode, Scott talks with Bill Steele about his 3D printing Kickstarter, the Ultrabot.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and today I'm talking to William Steele. Bill Steele, creator of the Ultrabot, a modification of a popular 3D printer. How's it going, Bill?
Good, Scott. How are you?
I'm very good. So I'm starting to think about 3D printing. I've talked to Pete Brown about this a couple of times. The kids are always breaking toys and plastic stuff, so I've got this idea that I'll just put my 3D printer next to my inkjet printer, and when, G.I. Joe loses an arm, I will just print out a new G.I. Joe arm. How close is that to being real?
Actually, that's exactly what I do already for my granddaughter. I'll come up with a little toy, draw it in Google SketchUp or something like that, and just send it right to the printer and make it. An hour later, she has the part or the toy.
Really? That is crazy.
Yeah.
That is amazing. Okay. Well, let's start at the basics then. So 3D printers kind of got their kick in the butt when a thing called the Makerbot Cupcake came out. And you talk about that and why did that change things?
Yeah, the prior to that, prior to the open source community effort around 3D printing, 3D printing was left for big manufacturers with lots and lots of money. That was, starting in the early 80s, and those machines were really, really expensive, and the parts they produced really weren't, you couldn't use them for anything. And then several years ago, I believe in 2005, 2006 timeframe, a gentleman over in England named Adrian Boyer developed a machine called the RepRap, which was an open source 3D printer designed to self-replicate, designed to be able to produce its own parts to allow a new type of economy, if you will, where we don't have a supply chain, we simply have a machine that produces the parts locally. And he thought about it, and he thought it would be really neat to have a device that was able to self-replicate, much the same way that a plant and an animal have a symbiotic relationship. He thought maybe a human and a printer could have a symbiotic relationship where one supplies the other one material, and that allows one to reproduce, and then the benefit is it also allows it to be used for other things, creating little knickknacks and toys and whatnot. And that first product that he produced was called Darwin. And right about that same time, a group of guys up in New York City got together, and they decided that they wanted to use a laser cutter to make a 3D printer. And they designed a machine around the original Darwin that they called the Makerbot. And their first product was called the Cupcake. And the Cupcake was given its name simply because one of the guys on the team, Bruce, actually liked to cook, and he realized that this 3D machine could be used to actually decorate a small cupcake. And the machine could actually make a part about the size of the cupcake as well. And that actually led, into the product that he called the Makerbot Cupcake, which was the first, really mass-produced 3D printer that you could just go buy. And when I say mass-produced, it was actually low volumes. They probably sold 3,000 of them total. But they were kits, and, hobbyists like myself purchased them, and, we built them and played with them for years. And during the playing of them, I realized that there was a need to improve it, specifically for my own use. So I thought about redesigning some of the components and redesigning, the way the whole unit kind of worked to better suit my needs. And that's kind of what led me down the path today where I am with the Ultrabot.
So the Makerbots, the originals, they were made of wood, right?
Yeah. Yep. the original Darwin was actually made out of threaded rods and plastic parts that could be printed on another printer. You went to the hardware store and you bought a whole lot of parts. And then the Makerbot guys, they had their laser cutters, and they thought, wow, we could really speed up the process of manufacturing these things if we use laser cut parts. So that's what they did. They used a nice birch plywood, and that actually made it really easy to assemble the printer, kind of like an IKEA furniture setup. Building them became, instead of being a month or two long process, got it down to 4 or 5 days. You could easily build one of these printers. And that was actually one of the things that I changed in the design. I really like the idea of laser cutting, but I really didn't like the idea of having a wood chassis, because first off, it's a wood chassis. It looks like a wood chassis. It acts like a wood chassis. It creaks, and it's fragile, and it's you don't want to get it wet, for example. So I redesigned the case in acrylic. So my case is pure clear acrylic. It's actually quite nice looking when you look at it. I get all kinds of compliments because of the way the machine looks. It actually lets the little kids actually see what's going on. When somebody comes up to look at the printer, they can see all the moving parts inside of it. All the gears and the pulleys and the belts and the motors and, everything going on inside of it. And that lets them open their mind up a little bit and say, wow, this is kind of neat.
So fundamentally, how does this work? I mean, I think that we all understand, or at least I understand, how an inkjet printer works. You've got this ink in a cartridge, and that ink then gets dripped out onto the page. And I assume that there's some heat and some electrical stuff going on. How can I print something in 3D? What is my ink?
That's a great question. The ink is actually plastic, and we use what's a welding wire, basically. It's just a 1.75 millimeter or a 3 millimeter filament of wire, plastic wire. And what we do is we very much like a soft serve ice cream machine or a hot glue gun, we extrude that plastic out. Now, the way we extrude it is we drive through a tube into a hot end, a heated nozzle, and then we simply move the nozzle over our build surface. So just like I was building an ice cream cone, if I would turn the nozzle on to start extruding the soft serve ice cream, I would place the cone under it and move the cone around to give it the shape, the spiral shape of the actual ice cream cone. And then when I got to the top of it, I just shut the ice cream maker off, and that stops the extrusion. And when I'm done, I'm left with a cone-shaped ice cream treat. We do the exact same thing with the plastic. We move the Makerbot actually moved the part underneath the extruder. My new design actually moves the extruder over the part, so it's a much smaller piece moving around, which gives me a much larger build area. But I basically just melt the plastic and kind of, just like you said, dribble it onto a surface that's designed to catch that plastic. And then the next time, when I draw the very first layer, I get done, I move the extruder up just a shade, just a fraction of a millimeter, and then I draw again. And then I move it up again, and then I draw again. And I keep doing that until I get, 100 or 200 layers later, the part actually made in 3 dimensions.
Okay, so let me see if I get my head around this, because we are doing an audio podcast and not video, although people can certainly go and see video of this happening at ultra-bot.com. So the original Makerbot had a plate, and by plate, it's just literally a square that you're going to print onto. And right. And the extruder is the nozzle, the thing that makes the kind of the design as if you were making drawing on top of a cake. And the original right. Makerbot would move the plate or the nozzle. Yeah, it would move the plate. It would move the whole cake around. Really? Okay, so it would move the nozzle. Entire thing you're printing underneath a fixed nozzle. Right. Yeah, mine is moving the nozzle over the top of the cake. And then, which makes it, the nozzle is much smaller than the cake is, so I can move it much further, which allows me to create a part. Well, in reality, the UltraBot can actually produce a part about 6 times the volume of the original Makerbot.
in the exact same size chassis. It literally is the exact same chassis. In fact, I use all of the major components from the original Makerbot Cupcake can actually be moved into an Ultrabot. That's one of the upgrades that we did is, for all those 3,000 Makerbot owners out there, they can actually upgrade their unit to an Ultrabot simply by buying a new chassis and a couple other minor components. They can reutilize their nozzle, their drive system, all the motors, the electronics, everything. Just ports right over to the Ultrabot.
Why isn't this obvious? I mean, it seems obvious, as with all good ideas after the fact, you think, wow, that was obvious. Why would they make that decision to move the entire object underneath a fixed nozzle and have those limitations?
They actually had a very good reasoning for it. When they designed the cupcake, they actually had a couple of restrictions that they had to deal with. One of them was that some of the technology that I'm using hadn't been invented yet. For example, they needed to have the extruder drive mechanism on top of the extruder. Nobody had developed what we call the Bowden style extruder, which is the drive motor separate from the actual hot end of it. Mine are separated by about 2.5 feet of silicone tubing. Now, what they actually did was they realized that with their system and extruder packaged together, that weighed about 1.6 pounds. So they actually realized, in their design, that their parts, because they were, limited to 4 inches, it was a lot easier to move the part than it would be to move the extruder. But since then, the 3D printer technology has evolved, and there's been a lot more input on it, let's put it that way. And there's been a lot of new ideas that have been, applied to 3D printing, that I simply applied to their old design. So I kind of removed some of the constraints that they had with newer technology.
So the extruder is the fundamental, that's the thing that could be most improved when one is doing this. Just like there was a time when inkjet printers would do 150 DPI and then 300 and then 600 and now 1200. And it was all nozzle-based stuff. It wasn't the moving around of the paper. It was the improvements in the nozzle. Right.
Yeah, that's actually one of the other technologies that we've done. When they originally designed their printer, it was designed for 3mm filament. And the extrusion technology hadn't been fully developed yet, so they had a 0.5 millimeter, basically, resolution, if you will. And that, because they were using a 0.5 millimeter nozzle, and the temperature controllers and everything, hadn't been fully realized that we have today. In my design, there was another reason for that too, and that's the electronic controllers that drive the motors were at the time set up to drive stepper motors one full step at a time, and the electronics that do what we call 16th stepping hadn't been developed yet. So the original Makerbots could produce parts, but they were very, very rough, coarse, 0.5 millimeter resolution, if you will, on the axis. And with the new electronics driving 1/16th step, that automatically gives us much, much finer control over the motors and positioning. And then the advent of using 1.75 millimeter filament allowed us to use much smaller drive systems, as well as to control the filament faster. We can actually do things with the modern filaments that we couldn't do previously. For example, when you move to the end of a line and you want to change layers or you want to move to a second part, on the old Makerbot Cupcake, we had a DC motor that would simply stop spinning, and as the head was moving, the plastic that was in the nozzle would kind of drizzle out, and it would leave a string filament between the two parts, and you would have to shave that off. With a modern setup, we actually use a small stepper motor to drive the extruder instead. And with the stepper motor, we can actually quickly reverse it when we get to the end of the line, and that quick reversal will actually suck the plastic that's right at the end of the nozzle back up into the nozzle, so that it doesn't dribble out. And then we move over to the next part, and right before we get to the part, we start the nozzle back up a little bit earlier than we would have normally, and that repopulates that nozzle with that melted plastic, so that when it starts to extrude, it's instantly there, and that made the quality drastically improve, just by incredible amounts. simply by adding a little bit of logic and a little bit of more, a little bit more technology there. And the nice thing is this is a very, very simple change that now every single 3D printer out there that is, from the open source community uses this exact same technique.
So that's interesting. There's two questions there that kind of came up in my mind. First is there's logic. So there was a software change where someone said, when you're moving, add a little, for lack of a better word, a little body English on it, put a little spin on it, and things improved. And then there's also the actual physical changes to the device itself in the improvements in the extruder and in the motors. Did the stepper motor not exist, or was it just that no one had ever gotten around to saying, oh, we should use a stepper motor? Duh.
It was the second one. The stepper motors existed because we're using the exact stepper motors that we used on all the other axes. The X, Y, and the Z axis, they use the exact same motor. It's just that for some reason it was never applied to the extruder at that point. But you're right. That the software change was also required. That little bit of English, I love that term, that you apply to it. That's actually done, in the software that actually calculates the what we call the tool path. So when you create a model, you create it in a tool like AutoCAD or Google SketchUp or something like that, and then you convert it into what's known as an STL file. An STL is a stereolithography file. It's basically a file designed for 3D printers. That then gets what we call sliced. Slice here. There's a couple different programs that do that, but it slices that STL file up into the layers, and then it calculates the tool path, the extrusion motion over the build surface, which generates all the logic to that we actually feed the printer itself. And that tool has seen some pretty drastic pretty drastic changes just by itself. For example, the original version used a tool called SkeenForge, and this SkeenForge tool would take quite a while to process an STL file into the appropriate G code, and it was also pretty coarse. You had to do a lot of hand tuning to get it to work. Now with the modern software, there's a simpler tool called Slicer, and that Slicer tool, you really just tell it the diameter of your nozzle, what the material is, and how big your build area is, and it calculates everything else for you, and it works incredibly quick. It's about it's probably 5 to 10 times faster than the old SkeenForge engine was.
When I plug one of these into my computer, am I just plugging this into a USB port, and what does it show up as?
It actually just shows up as a USB port with a serial. It's just a serial port to the actual computer. We do pretty much serial over USB, and the software is just looking for that virtual serial port. So, for example, the default serial port that I have on all my machines is COM3. Because that's the last one that's generally
Really? So
added.
this is just like those old style, RS-232 to USB adapters. I plug it in and it says, oh yeah, I've got a serial port. So I assume there's no driver needed because those virtual serial ports are built into Windows now.
That's exactly right. That is exactly the way it works. That makes it easy. It works consistently across all OSs. So, for example, the software that I use to drive the Ultrabot is called Pronterface, which is a UI on top of a couple other packages like Slicer, and there's the actual calculation engine that we call Printer Interface. But those packages are they're portable packages. So the entire Pronterface package, for example, will run on Mac, it'll run on Linux, and it'll run on Windows with no problem. And it's just the install that you want. In fact, what I was doing yesterday was I actually built a package for iOS and the Linux environments that you could just do a get at and install it.
Mm-hmm. So bear with me as I try an extended analogy here to get my head around how this works. Around 1989 or 1990, I was installing an Epson FX80 dot matrix printer.
Yep.
likely onto, I think it was either a 286 or something, and I was running like Paperclip or some really old, or maybe WordPerfect, but even before WordPerfect, okay? There was no concept for a printer driver at that point. You got a spiral notebook full of codes. And you installing a printer meant that I would sit there for, 4 to 6 hours and type in codes to say, here's the control code to make bold, and here's the control code to make, italics. And, about a year and a half after that, of course, that became very tedious. And then the word processor itself would start to support that printer, and you just select it. So basically the idea was, rather than the user entering in all the details, that got moved upstream to the word processor vendor, and then that got moved upstream to the printer vendor, and then that got moved up to the OS itself.
Correct.
I'm kind of hearing you say, in the world of 3D printing, we are going through that process. This is not baked into the operating system.
We've pretty much done that same process, except that we didn't go to the OS layer. We have an abstracted out language called G-code. Now, the idea isn't just in the 3D world. It's actually all CNC machines use this language. It's a common language called G-code, and it's just handled over serial connections.
What is CNC? Let's make sure we explain all of our acronyms for our listeners.
Oh, CNC is computer numerically controlled. So there's mills and router tables and, planing machines. There's all kinds of machines that can be automated with computers. Mm-hmm. That language that they use is a common language. It's called G-code. And G-code was developed, I think, literally way back in the 60s or early 70s. And pretty much every machine has adopted that approach. The G-code platform itself, the language itself, is extensible. So you might have a generic version where you say, move the x-axis to this location, and then there might be a machine-specific code that says, okay, turn the extruder on at a temperature of 205 Celsius. So there's adaptations for the different machines. But there's a standardization across most of the communications protocol and everything else that goes with it. And the way we actually configure the software is we basically tell it what kind of a machine we have. And the generic form of 3D printer that we use is what we call a 5G machine. So we use that version of the protocol, and that's kind of built into all the firmware of the printers to understand that version of the protocol.
Mm-hmm. But it seems like there's a level of complexity for the average user. Like, you described, the speed at which it goes and how it talks to the motor and all these kinds of things. That would be like me telling my dot matrix printer how fast to turn the paper and how hot to make the ink and how quickly to go back and forth. That's not something that I think my wife or my mom or my dad would want to do. Will that ever be abstracted away entirely, or will I always have to know about
that? That is abstracted away right now. That's what the slicer software actually does. You tell it that you're printing with ABS, and it knows what temperatures to run the extruder at for ABS. And you tell it how big the filament that you're using and how big the nozzle is, and that's a one-time setup. That's pretty much standard across the machines. You're either using 1.75 or 3 millimeter filament. And then it can calculate everything else based off of that. So, it's a one-time setup. You're plugging in, 3 or 4 values, and it's configured for the machine.
Okay. So this is cool. So I'm sitting here with in my hand, and I'm looking at a adapter that's like a plastic adapter. Have you seen these dongles that you plug into your Mac, and they've got like VGA on one side and something else on the other side? And it's got like a nice plastic cover on both sides. It's very smooth and curved. And I'm trying to kind of think to myself, I could improve on this design. I could change this. Could I build something like that? And would it, how close to this polished Apple dongle would it look?
Well, you can build something like that. Because we are building things up in layers, you are going to see the layering effect of it on most of the surfaces. So if you have a cube, there's 6 surfaces. 5 of the surfaces will have some kind of texturing. On the bottom surface, the build plate is very flat. So when you extrude onto it, it actually will fill up any voids, and it will make that surface incredibly smooth. but all the other surfaces will have some kind of texturing on it because of the layering. And that texture and the depth of that texture is going to be dependent on your nozzle, how big your nozzle is.
Mm-hmm.
The finer the nozzle, the higher the higher the quality of the part, if you will. But there is a downside to that. The higher quality parts actually take a lot longer to print because for a 0.25 millimeter extruder, it's going to take 4 times longer than a 0.5 millimeter extruder to extrude the same diameter of filament.
So this sounds like the kinds of things with like draft mode versus best versus photo paper on my inkjet. Right? Do I want it fast or do I want it good?
Right, and that's a trade-off you have to make with the nozzle selection that you use. Now, that's not saying you can't swap out the nozzles, right? You can easily do that. The other option is to actually go with a printer that has multiple extruders. These are actually becoming easily available now. For example, the latest Makerbot, what they call the replicator, actually has 2 nozzles, from the factory.
Mm-hmm.
So you can have 2 different materials, 2 different size nozzles, 2 different colors. So you can, make parts with a draft nozzle and a high-end nozzle, high-quality nozzle. In fact, the Ultrabot, this is actually breaking news for everybody. The Ultrabot actually was designed from the ground up for being a dual extrusion device. So it actually has support for having 2 extruders built into the unit.
Now your Ultrabot, people can see this at ultra-bot.com. Yesterday, you launched a Kickstarter, and a few hours later, you completely funded your Kickstarter, and you still have a month to go.
Yep, funded, 100% funded in less than a day. That was awesome.
Yeah, it is cool. So you've got a couple different levels here. Help me understand these levels. For example, I see there's the people who already have Makerbots can upgrade for like $200, $300. But at the lowest complete level, you have a $799 level that gets you a complete kit unassembled.
Yeah, the $799 is the unassembled without the heated build platform, which is great for using a plastic called PLA, or polylactic acid.
Mm-hmm.
PLA is a plastic that is made from cornstarch and sugar, and it smells great when you make parts with it. It smells like you're cooking waffles.
Mm-hmm.
It's actually friendly in the home kind of plastic. The next level up from that is $100 more, which includes the heated build plate. You need the heated build plate if you're going to use plastic called ABS. ABS is the same plastic that Legos are made out of. It's a very, very hard material. The PLA is more sugar-like, if you will. It's a more brittle material, but it's harder. Mm-hmm. But under normal use, you're not going to break either one of them. So they're both incredibly strong plastics, and they're both very, very easy to use with a 3D printer.
Okay. So I thought
the $100 gets you the electronics, the heated build platform, and the other necessary upgrades to actually support the ABS plastic.
Okay, so I misread that. I thought that the one that says this printer is not equipped with a heated build platform meant that there was a missing part and I could not print right off the bat. So I can.
Oh, yeah.
For $799,
No.
I could print something immediately as soon as I put the thing together.
Exactly. Yep. When you're using PLA, the build surface, the only thing that I've ever used for a build surface for PLA is simply blue painter's tape. That happens to be the best surface that everybody in the community has found for printing on, for using PLA. It just works beautifully, and it's very, very inexpensive.
Mm-hmm. So you've completely funded your Kickstarter, but of these multiple levels, the unassembled, ready for PLA, ready for ABS, and then the fully assembled, you're selling ones, at least on Kickstarter, that are completely assembled and include the build platform. Why do you think people are spending the extra money?
To tell you the truth, this is, I think, the biggest miss in the community out there right now, and the fact that having a fully assembled unit for a reasonable cost is a product that was lacking. Most people do not want to build their own units. They want to just like you don't go to Best Buy and buy an HP printer unassembled, right? You buy it assembled. They want to, have the enjoyment immediately when they take it out of the box, and that's kind of the market that I wanted to fulfill. Having a completely built unit that was available for anybody to use, that for somebody that thought they didn't have the time or the skills or, just the desire to actually assemble the unit themselves. The other thing that I want to target is really the education market, and that's a market that, kind of like what Apple did in the early days. They had units that were low cost available to schools. This is really where the big advancements are going to come from. These kids are going to see this technology, and they're going to understand it, very, very early on and incorporate it into their lives. Just like we're seeing today with computing. Computing when you and I were kids was, well, actually you're a lot younger than I am, but when we were kids, computing didn't exist in the home. And, then along came the Apple Ones and the Apple Twos and, machines like that allowed us to tinker and explore. We're really in that phase right now with 3D printing. We've got guys that are building their own printers and, doing that, and that's great. But where are the Apple Twos of the world? That's where we need to move. And Makerbot kind of stepped into that with their newest machine, where they sell their machine only as a completely assembled machine. And that's good, but still, kind of out of reach for a lot of people from a price perspective. So their machine is about $2,000, and I thought, well, we could really provide the same kind of thing for a lot less, and in my opinion, make a better looking machine. Because in fact, theirs is still wood. So there's lots. So to be clear to people, there's lots and lots and lots of different choices out there, and explore, because I'm sure that there are literally dozens of different kinds of printers that they could use. But yours is a improvement, an enhancement on the original Makerbot. It is of your own design, that it kind of inherits from the good things and improves the things you didn't like. But it's effectively an advancement on the Makerbot Cupcake that allows you to print much, much larger stuff. Exactly. Yeah. And you said it earlier. There are a lot of choices out there. And, if you're in the market for a 3D printer and you want to do a kit, or you want to do, you want to learn about it, there are a lot of great machines that are a lot lower cost. I mean, no kidding. There's machines that you can buy for $400 or $500. Remember, it's a $400 or $500 machine. In a kit form, you're going to get a lot more for your money than a pre-assembled unit, and that's going to show through. But the idea is that what I personally want is I want the awareness out there, because I honestly believe that 3D printing is simply going to change the economics of the future. Today we have a supply chain that stretches to as far as China and central China, and if I want to buy a comb, it's for some reason it's cheaper for them to produce that comb all the way in China and ship it all the way across the oceans and warehouses in these buildings and do all this stuff for me to go buy this comb for 99 cents hanging on a rack at a dollar store. That's mind-boggling that things are that cheap. But if we could eliminate all of that other stuff in between by using a device like this, we can, for example, bring back manufacturing to the U.S. and make it, get us back to the point in the world economy where we belong. So, for example, that same comb. If I wanted to print a comb, in fact, the comb that I have in my back pocket right now is a copy of the old black unbreakable comb that I printed on my printer. It took maybe 15 minutes at the most, and I didn't have to go anywhere to do it. It's made out of ABS plastic, and it works just the exact same way as any other comb I've ever had. Right,
and you didn't have to get in your car and drive to Walmart to do it. That's fantastic. So people can learn more about your UltraBot at ultra-bot.com. I'll add a link in the show notes for people to check it out. And there's multiple videos up there that will give people an idea of how it works, and they'll be able to see it in action and then talk to you and leave comments and learn about how 3D printing works.
Yeah. Yep.
Fantastic. Well, thanks a lot, Bill, for taking the time to talk to me.
Well, thanks. Thank you so much, Scott.
This has been another episode of Hansel Minutes, and we'll see you again next week.